Machine learning and AI for health. How do we define health informatics? Health informatics is the interdisciplinary field that combines healthcare, information science, which is the study of how information is collected and how people and systems interact with information, and technology to improve the way health information is collected, stored, and managed. The goal of health informatics is to ensure that health data accurately supports patient care, medical research, healthcare, and decision making. In simple terms, health informatics uses technology and data to make healthcare safer, more efficient, and more personalized. How do we define AI and machine learning? AI is the broad field of computer science focused on building systems that can perform tasks that usually require human intelligence. These tasks include problem solving, reasoning, understanding, and decision making, and recognizing patterns. AI can be rule-based, where systems follow programmed logic, or even learning-based, where systems adapt and improve over time. Machine learning is a subset of AI that allows computers to learn from data rather than being given explicit step-by-step instructions. Machine learning systems use algorithms and statistical models to find patterns, make predictions, and improve their accuracy as they are exposed to more data. This makes machine learning a powerful tool for applications like recommendation systems, medical diagnosis, fraud detection, and speech recognition. What can AI do? Well, AI can understand and analyze large data sets, make predictions, provide information, recognize patterns, and as well as automate tasks. AI is used in more industries than you might think. In everyday life, we use AI like Siri and chatbots like ChatGPT. Even the social media sites and other public sites have AI running in the background. For business, they can use AI to automatically respond to customers, sort through mounds of data, and automate tasks that would otherwise have required someone to have done it. In research, AI can do similar things like analyze data, automate tasks, but it can also be used to help narrow down scientific papers, which I'm sure anyone in university can appreciate. AI is often used in our daily life, regardless as if we know it's there or not. Think about when you start typing in Google and it's already guesses what you want to search. That's AI. Browsers also suggest articles, videos, or news based on what you usually look at, so it feels like it knows your interests. Even the ads you see are powered by AI, which tries to show things you're more likely to care about. AI can also make images for you. Tools like Dolly or Midjourney can take a text description, like a man thinking with a light bulb above his head, and turn it into an image. AI also helps edit photos automatically, like removing backgrounds, sharpening images, or improving resolution, so you get professional-looking results without doing much work. AI also runs a lot of what you see on social media. It decides which posts, videos, or stories appear on your feed based on what you like or interact with. It also powers fun filters and effects, like changing your background in a video or adding AR effects to selfies. Plus, AI works behind the scenes to catch spam or inappropriate content so platforms stay safer. AI can also make writing a lot easier. Tools like Grammarly or Microsoft Editor check your grammar, spelling, and style as you write. They can also summarize long documents into key points, saving you time. And if you're stuck, AI can help draft emails, essays, or reports, giving you a starting point to work from. AI is also very often used in business. Think about when you visit a website and a little chat window pops up asking if you need help. That's AI. These chatbots answer questions 24/7. They'll track your orders, and they'll troubleshoot problems without a human input. AI can also read customer reviews or social media comments to figure out if people are happy, frustrated, or upset, so companies can fix problems before they get worse. It can even predict what you might need next, like suggesting a solution based on your past questions. AI is like the brain behind getting products to you faster and cheaper. It figures out the best delivery routes so trucks don't waste time or fuel. It also predicts how much stock a store will need, so there's not too much or too little. On a bigger scale, it helps companies plan their supply chain by analyzing trends, like knowing which products will sell more during holidays. AI is also very important in finance. It can spot suspicious transactions that might be fraud. It can also take care of tedious tasks such as categorizing expenses, reconciling accounts, and generating reports, which saves accounts tons of time. On the investment side, AI can analyze tons of market data to predict trends and assess risk, helping businesses make smarter decisions with their money. Companies also collect mountains of data, and AI helps make sense of it. It can highlight which products are selling best, which regions are performing well, or even forecast customer behaviors. Businesses can run simulations with AI as well to see what might happen if they try different marketing strategies. This way, managers can make smarter, data-driven decisions rather than just guessing in a low-risk environment.
The use of AI in health informatics. As we now know, AI is principally utilized to organize and distinguish between important and unimportant data. This can be used extensively in health informatics to help diagnose and analyze vast quantities of information. AI and machine learning can be used to recognize patterns and trends in the data. The application of this can range from actual diagnostic work that helps alleviate some of the work from doctors, to sorting through new medical data and files to organize or find patterns. AI use in this way helps improve efficiency and, if used properly, accuracy. It can help save money and lives by completing tasks that would otherwise take much longer. While automated machines have begun to take root in the physical realm of healthcare, they are only just beginning to be considered AI. AI relies on data capture and processing, and in order for there to be a successful surgery, it has to be personalized to the subject being operated on. If it were all pre-programmed, it would be difficult to program for each individual. This use of AI has given automated surgery a future. However, these are more recent developments, and it has been much easier to use AI in health informatics rather than in physical practice due to the nature of the work. Problems in health informatics. Another challenge is clinical decision complexity. Physicians must interpret vast amounts of information under time pressure, which increases the risk of misdiagnosis or missed findings. Similarly, medical imaging workloads are growing rapidly, and the interpretation of scans such as X-rays, CTs, and MRIs can be time-consuming and prone to human error. Predicting patient outcomes is also a persistent challenge. Identifying risks such as sepsis, hospital readmissions, or disease progression often relies on reactive rather than proactive approaches. Finally, data quality issues, including missing, inconsistent, or incorrect entries in health records, compromise both patient care and research reliability. These challenges collectively highlight the need for advanced tools to support clinicians and improve management of healthcare information. Solution to the problems in health informatics. Artificial intelligence offers a range of solutions to address major challenges in health informatics. For data overload and fragmentation, AI can use natural language processing and advanced integration algorithms to extract, organize, and summarize patient information from multiple sources, giving clinicians a complete and coherent view of a patient's history. In tackling clinical decision complexity, AI-powered clinical decision support systems can highlight abnormal results, predict disease progression, and recommend evidence-based treatment options, reducing cognitive load and improving decision accuracy. Regarding the medical imaging workload, deep learning models can rapidly analyze X-rays, CT scans, MRIs, and pathology images to detect anomalies such as tumors, fractures, or hemorrhages, saving time and complementing radiologists' expertise. For predictive challenges, machine learning algorithms can identify patients at risk of adverse events like sepsis or hospital readmission, enabling earlier interventions and better outcomes. Finally, to address data quality issues, AI can detect inconsistencies, fill in missing values, standardize formats, and flag errors, ensuring that clinical decisions and research are based on reliable, high-quality data. Current uses of AI in health informatics. AI can help diagnose diseases based on medical data. This not only can be simplistic matching symptoms to diseases, but can also include treatment options based on the data gathered and knowledge on the disease. AI currently does not have enough support to wholly make these diagnoses on their own. However, as a tool to assist healthcare professionals, it can be advantageous. Some of these diagnoses can be done by data, but others will most likely make use of image analysis capabilities of AI. Some examples of images that AI could analyze would be samples of cells to look for cancer, or radiology graphs such as CT scans, X-rays, and MRIs. The image analysis can detect important signals much more precisely than humans can, and can save professionals a lot of time. AI can also be used to navigate personalized health records. This is mainly to save time and make relevant information more accessible and convenient. It can also assist with those responsible for the financial and other behind-the-scenes facet of healthcare system. It can help manage finances and assist with off-hours health support and information directories. Lastly, AI is useful in tracking disease levels in a population. It can monitor outbreaks and summarize important data, which is helpful for those in charge of making decisions. This can help predict hospital demand and the impacts of levels of disease on the population and the functioning of society. Some real-world examples. So, this section is to touch base on what this would look like in a real situation. To begin with, in a clinic, a professional asks a patient about their symptoms and then enters the information into a computer. The AI program on this computer looks through the data, compares it to the information it currently has in the database, and makes a conclusion on what the disease is logically, based on the information that the physician gave it. This can help save time, and it can also help the professional be more certain of their diagnosis. Another example is a picture of a tissue. The cells on these tissues are very small, but the physician wants to know if there's any cancer cells present. It is much more expeditious to use AI to search for cancer cells, rather than search through it all with a human being manually. The accuracy of AI in these circumstances is high enough that it is regularly used to scan tissues and images today. Health information is likely the most practical use of AI. Inputting data and having AI retrieve and organize it is very useful. For instance, the professional needs to know information on your file. So, they use an AI tool to find your file, retrieve the relevant information from multiple sources, and then put it to use. The professional then uses AI to calculate how much money insurance will need to cover, and how much that money will cover for your health care. In another scenario, there's an outbreak of Ebola. Health informatics experts use AI to track how the disease has moved through an area geographically, and then using that data, they once again rely on AI to calculate the spread. Once calculated, the professionals use AI once more to contact people who are in the red zone automatically, very easily and efficiently completing the important tasks.
I am your narrator, Rudral Oza, for the further slides. The topic I will be talking about will be future and directions to use of AI in health informatics and healthcare. And we are starting with precision medicine. So now what is precision medicine? It means treating patients with the same instead of treating patients with the same targeted therapies that are being done right now. Treatments are more customized based on their individual profile. And the most driving factor for the rise of popularity of precision medicine is, as you guessed it, AI. And this includes several factors like genetics, lifestyle, past medical history, and even environmental exposures. What AI helps us here is it helps us shift through millions and millions of data points to match a patient with the most effective treatment. For let's consider a real life scenario. Like right now in cancer therapy, AI systems can analyze a person's DNA mutations and predict which drugs are most likely to work. Several drug trials have already made use of AI to identify patients who respond better to targeted therapies. This not only helps us improve the outcomes, but also drastically reduce the side effects. Since patients don't waste time on treatments that aren't likely to help them. Moving further, we talk about integration of the said huge data and help of AI in genomics. Now, what is genomics? It means it is the study of our DNA. And AI has a really powerful application here. But there are certain problems to the application while we have some solutions while we are also searching for others. Genomics has the potential to reveal why some people are more vulnerable to certain diseases than others. Thus, it has created these sad problems. First, privacy. Privacy is a major concern of ours. A person's genetic code is the ultimate personal identifier, and if leaked or misused, it could lead to serious consequences such as genetic discrimination, misuse of the said information to target others. Second, the cost of sequencing DNA and building AI models around it is still very high and expensive, which makes it difficult for many healthcare professionals in hospitals or countries to adopt. Third, underrepresentation in datasets is a serious issue. Most genomic studies are based on European populations, which means other groups are underserved or misrepresented. This could cause unequal healthcare outcomes. And finally, interpretation issues also exist. Even if AI detects a genetic variation, we may not know whether it truly causes a disease. Doctors can't always act on AI predictions unless they are clinically valid and explainable. Fortunately, some of the solutions are emerging to the to address these set problems. For privacy, as we talked about, genetic data can be protected with stronger encryption, secure storage systems, and stricter laws like GDPR or HIPAA, which are starting to be implemented in some of the said countries. To reduce costs, governments and international organizations are investing in large shared databases and cloud computing, which lowers the barrier for hospitals and research labs. Tackling biases require building more diverse genomics datasets. This means people from different ethnicities, regions, and health backgrounds can use this set data and upgrade and update it. So AI models benefit everyone equally. And for interpretation issues, as we will talk about in further slides as well, explainable AI is still being developed and is in the phase of being a rapid is in phase of being in a rapid development. These systems don't just give predictions, they also show why a mutation is linked to a condition. Genetic counselors can then work alongside AI to guide patients properly. With these improvements, AI could become a key driver of personalized medicine in the future. Moving further, We go on about ethical and explainable AI. As we talked about in last slide, what really is explainable AI? We'll get to know about it in this slide. A major concern in AI in healthcare is the black box problem. While you guys may not know what black box problem is, it just means many AI systems generate answers without showing how they reach them. And it is a very, very important concept of understanding the why behind the equation. Imagine that an AI is telling a doctor that a patient has a high risk of heart failure, but not explaining why. The doctor would hesitate to trust it. This is where explainable AI or XAI comes in and is so important. It makes decisions transparent. For example, if an AI predicts heart disease, it might highlight factors such as high cholesterol, smoking habits, or family history. This helps doctors validate the decision and give patients confidence that AI isn't just guessing. Here, ethics also matters. If AI is trained mostly on one group of patients, it can be biased against others. Fairness in training data is essential as well. There's also the issue of accountability. If AI makes some mistakes, who takes responsibility? The doctor, the developer, the hospital? Clear regulations are needed here, and clear hierarchy needs to be set up. Government and health organizations are pushing for updated rules so that AI in healthcare is safe, fair, and transparent moving further. We talked about how AI can be helped, how AI helps in doing it. But the key component in in AI in healthcare booming is collaboration. For AI to truly transform health informatics, collaboration is key. Doctors bring medical expertise, AI developers bring technical skills, and while policymakers set the rules, without all three working, progress will stall. This is why it is a key component for AI to boom in healthcare and help progress. Another important point in training healthcare professionals, doctors, nurses, and technicians need to understand how to use AI tools, interpret their outputs, combine them with clinical judgment. It's also important to stress that AI will not replace doctors. Instead, it will act as an assistant, handling repetitive tasks like analyzing scans or summarizing patient histories, while doctors focus on empathy, decision making, and patient care. With responsible use, AI can ensure fairness, trust, and safety. In conclusion, AI is no longer a futuristic concept in healthcare. It is truly reshaping health informatics today with ethical and responsible use. The future looks very promising. Thank you guys. That was my time. I hope you guys have a very, very good day.